Before we can make a conclusion, which is our next learning target, we have to be able to make calculations to figure out the specific heat of our unknown metal. So to do that, I'm going to walk you through some calculations that you need to do. So over here we have our data table from our lab, and the numbers here in red are the numbers that we're going to need to use for our final calculations. So we have the mass of the water that was used, we have the mass of the unknown metal, we have the change in temperature that occurred for the metal, which came from subtracting our initial temperature minus our final temperature, the difference we get here. We also did the same thing for the temperature of our water. We subtracted our two temperature values and got our difference in temperature. So we're going to use these red values to do our calculations so we can eventually get to the specific heat of our unknown metal. So our first step is that we need to take averages of these measurements because we ran 3 trials, so we want the average of our 3 trials together. So the first thing we're going to do is find the average mass of water. So we're going to look over here at our average mass of water. We're going to add those values together. So we're going to add our 39.5 plus 40 plus 40.5. We add those values together, and then we're going to divide that by 3, the number of numbers that we added together. And that's going to give us an average of 40.0 grams. So you're going to do this with your data. If you are absent, you may borrow the data here in this video. Otherwise, you're going to use your numbers for trial 1, 2, and 3, add them together. Make sure you add first, then divide by 3. Our second step, we're going to find the average mass of the metal. So we're going to take these 3 values here, so 24.5, 25.0, and 25.5. We're going to add those 3 numbers together. Then we're going to divide that total by 3, which is going to give us an average of 25 grams. Our next step, we're going to find the average change in temperature of the metal. So we're going to look at these values here. We're going to add them together, so 73.2 plus 73 plus 72.8, which came from these numbers here. We're going to add those 3 trials together, then divide by 3 to get our average, which is 73.0 degrees Celsius. We're going to do one last average. We're going to find the average for our average change in temperature of the water. We're going to take these 3 values here. We're going to add them together. So we're going to have 2.80 plus 3 plus 3.20. We're going to add them together, divide by 3, which gives us an average of 3 degrees Celsius. Now we're going to use these average values, this 40 grams, this 25 grams, the 73 degrees Celsius, and this 3 degrees Celsius to do our final calculations. So the first step in finding our specific heat at the end is that we're going to calculate the heat gained by the water. So when the hot metal was put into the water in the calorimeter cup, the temperature of the water increased. So we're going to figure out how much heat that was. So to figure out heat, remember we're going to use our equation Q equals mc delta T. So we're going to set this up as Q equals our M. So our M is our average mass of water, which we calculated to be 40 grams. We're going to multiply that by the specific heat of water. This is a constant, which is a known, which is 4.184 joules per grams degrees Celsius. Then we're going to multiply it by our average change in temperature of a water, which was 3 degrees. So we're going to multiply these numbers together, and we get 502.08 joules. I'm not going to round this to significant figures yet because we're going to be using this in our next step when we want to wait and round till the very end. So our final step in our calculation is going to require a little bit of algebra. So I'm going to list my variables and try and figure out what I'm solving for. So I'm going to write down Q equals, M equals, C equals, delta T equals, and then I'm going to plug in my values. So my Q value is actually going to be what I calculated here in the previous step. So the heat that was gained by the water in the calorimeter is actually the heat that was given off by the metal. So I can use this number, 502.08, as my heat for my metal. So 502.08 joules is going to be my Q value. This time for mass, we're going to use the mass of the metal, which was an average of 25 grams, so those 3 trials averaged together. Then change in temperature, we had an average change in temperature of the metal of 73 degrees Celsius. That means that we're looking for our specific heat. So I'm going to set up my equation. I'm going to have my Q value, 502.08. I'm going to set that equal to my 25 grams times my specific heat, which we don't know, so I'm just going to leave it as C, times 73 degrees Celsius, which again was our average change in temperature of the metal. So we're going to do a little bit of algebra. We're going to combine like terms. So I'm going to simplify this by taking 25 grams and multiply it by 73 degrees. So now I will have 502.08 is equal to 1,825 times C. So now I want to get C by itself, so I need to undo a multiply, and the way that we undo multiply is to divide both sides. So I'm going to divide both sides by 1,825, and then when I do that, I'm going to have 502.08 divided by 1,825. It's going to cancel on the other side, so this value is going to cancel, so it's going to be equal to C. So 502.08 divided by 1,825 gives me 0.275 joules per gram degree Celsius. So this is my specific heat of my unknown metal, which I'm going to use in my next step to figure out my conclusion. So we need to make a conclusion. We need to figure out what metal this is. So if I look in our lab, we were given this data table that had the specific heat of a bunch of different elements. So aluminum and copper and iron and lead and magnesium, manganese, tin, and zinc. So we're going to look at this chart, and the specific heat that we calculated came out to be 0.275. It doesn't exactly match all of the numbers or any of the numbers that are listed, but it comes pretty close. So if we look, tin has a specific heat of 0.21, which is pretty darn close to what we calculated here. Not exact, but close enough. So I'm going to make the conclusion that the identity of the unknown metal is tin.